Welcome to the Algebra 2 skill video for skill number 85. I can translate between and use various forms of function representation. So this skill is basically going to be a wrap-up for several things that we've learned throughout the year, and what we're going to be doing is taking all the various functions, being linear, quadratic, exponential, and looking at those in the forms that we've learned about, which is as an equation, as a graph, as a table, or even as a verbal description of words. And the goal of this skill is to be able to move between those four forms fluidly. All right, we'll begin our notes on page 85A. And sometimes it's important or useful to represent a function in more than one way. Each way of representing the function has their benefits and pitfalls. I've listed a couple benefits for each of the four forms. An equation is useful for predictions. So if we know that f of x is equal to 20x plus 5, we could predict what happens when x equals 5. A table is useful for pattern finding. So if you had a table and you had 0, 1, 2, 3, 4, 5, 10, 20, 40, 80, it's pretty easy for us to see that each line in the table, it's doubling in value. And that will help us determine that it's actually an exponential equation. A graph is useful for visualizing trends. So you might have something where as you increase the price, you increase your profit, but there will become a point where your price gets too high and your profit starts to plummet. And that's useful for business because you want to figure out the price that's going to give you the maximum possible profit. And oftentimes the graph is the best way to see that. And finally, a verbal description is useful for understanding the problem. Oftentimes we're presented with the verbal description, and from that we extract the other three forms. Okay, so because each representation of a function describes the same relationship, you can often use one representation to generate another. So you might be able to take your equation and represent it graphically as something like a line. Or you might be able to take your table and represent that as an equation. What is that? 5 times 10 to the x. I believe that's the equation. 10 to the 1th, something like that. Actually, the equation is 5 times 2 to the x. We might be able to look at a graph and say, as we increase our profit, as we increase our price, our profit goes up until we reach a certain point. And then we start to have diminishing returns. So we should set our price for our product at that point. So that's a verbal description from a graph. The way this shows up on the skill test is I will probably give you a verbal description and ask you to generate the equation, table, and graph. So I show that in example 1. A taxi charges $5 for fare plus 60 cents per mile. Write 3 other representations of this relationship. So I gave you the verbal representation, and you can generate the equation. 5 plus 0.6 per mile. A table, at 0 miles it costs us $5. At 1 mile it's going to cost us $5.60. At 2 miles it's going to cost us $6.20. And then finally I created a graph where we start at the $5 and then every mile we go up 60 cents. So out 1, up 0.6, out 1, up 0.6. Another way this shows up on the skill test is taking a story and matching it to a graph. So I would give you a story like sales at a store climb through the week and peak on Saturday. And I would give you several different graphs. I might have a graph that looks like this. I might have a graph that looks like this. Maybe one that looks like that. One that does this. and you have to pick which of the graphs represent that story. So if they climb through the week, we probably have one of these two graphs, and they peak on Saturday. So at Saturday we have our highest sales, and then it drops off a little on Sunday. This might work if you had this being your Saturday, but it'll be clear which graph works. The next one says the number of bacteria in a dish double every hour until they reach a critical mass and stop growing. So on this graph here, we're not doubling, we're just growing at a steady rate. This one, we're actually dying off. This one, our population goes up and down, up and down. This one, our population grows and then declines, whereas the one I've drawn here, our population appears to be growing and at a faster rate, so it's doubling every hour, and then it reaches a critical mass, and then the population remains stationary. You'll have to, on the skill test, label the axes. So on this one, we're looking at time is passing and your population is going up. And at a certain time, when you reach that critical mass, your population then becomes stationary. So the axes on the top one, we've got days of the week and then sales on the vertical axis. So Monday's got low sales, Tuesday a little bit more, Wednesday more. Fridays it's pretty high, Saturday is your peak day, and then it drops off a little on Sunday. And finally, one last thing that I've included is a way to look at tables and use them to determine what type of function you're working with. So I pointed this out throughout the year, but it's good to review it because it's been a while since we've seen some of these. In your table, if you have a constant first order difference, meaning we go up 5, 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 that's going to be a linear function. Another example would be if you had 5, 6, 7, 8, 9, and then over here you had negative 12, negative 13, negative 14, negative 15, negative 16. Each of these cases we're going down 1. So we have a constant first order difference. So that's a linear function. A constant second order difference is a quadratic function. So when we look at the first order difference, we're plus 5, plus 8, plus 11. That's not constant. So then we look at the difference between 5 and 8, and we get 3. The difference between 8 and 11 is 3. So that second order difference is constant. And that tells us it's a quadratic function. And a third type of table, when we look at it, we have a constant multiplier. So from 10 to 100, we multiplied by 10. From 100 to 1,000, we multiplied by 10. When we have a constant multiplier, that means we have an exponential function. Maybe we have 4, 5, 6, 7, and over here what we have is 50, and then 25, and then 12.5, and then 6.25. And in each case, we are multiplying by 1/2. So there's your constant multiplier times 1/2. All right, the key idea and concept for this skill is being able to move fluidly between any of these 4 forms. Going from a verbal description to a table, equation, or graph is the most common way that I'll assess this, but we should also be able to look at a table and tell what type of equation it is, or look at a table and plot those points onto a graph, or look at an equation and graph it. So moving between these 4 forms is really what the skill is about. Thank you.